So let's start with the basics. Who here works for a company that they feel has deployed observability into production already? 4, 5 hands. Okay, all right, that's good. Who here feels that they have a good understanding of what the word observability means? Let's go to the other end of the spectrum. Slightly more hands, but interestingly, not everybody that put their hand up for the first one. Okay, so that's actually really good news, because that's pretty much what I was anticipating and hoping for. So it looks like we're going to have a fun 50 minutes. So a little bit about me. I work at Red Hat these days. I was lead architect for instrumentation at New Relic, and led the open sourcing of around about $600 million worth of intellectual property related to observability. Before that, I founded jClarity, which was a Java performance company that was acquired by Microsoft. And before that, I spent a bunch of time in banks. I don't live in London anymore, although it's lovely to be back here. I now live in sunny Barcelona, but I'm probably most known in the community for my work with the London Java community. Hands up if you're a member of or have been to a LJC event. Yeah, there should be more hands up than that. The LJC is a fantastic resource for those of you that live in London. It is one of the nicest technical communities that I've ever had the privilege to be part of, and I highly commend it to you. During that time, I helped organize things, and I helped found a bunch of things, including a product or project that you might have heard of called Adopt OpenJDK. But we're not talking about me, we're talking about observability. So this is what we're going to discuss. We're going to talk about observability. We're going to talk about a particular project that I'm involved with now called OpenTelemetry. And depending on time, because I've gone through the standard life cycle that all speakers go through, I can't possibly talk about that. I have nothing to say. No one will listen to me. Oh God, I've got way too much material. When I gave a version of this talk earlier in the week, what we're going to cover today in the next 48 minutes took about 2.5 hours. So we're going to go quickly, and I'm going to skip some things. So the JFR stuff we may have to skip, but I'll talk around it and we'll manage. Okay, sound good? So let's start with some basic facts. This is brass tacks. Recently published from New Relic. I know the folks who wrote the report. I wrote the original version of it back in 2020. According to their numbers, which is not a self-reported survey, but the result of tens of millions of JVMs speaking directly to New Relic servers, these are the numbers. 70% of Java workloads, as observed by New Relic, are already in containers. Java 11 and Java 8 are very nearly equal in terms of market share. Java 11 is slightly ahead. No non-LTS version has ever passed 1% of market share, ever. And contrary to Oracle's rolling update story, where people will upgrade every 6 months, because everyone knows that engineering managers love that. It's effectively Schrodinger's task. On the one hand, it's make work. On the other hand, it's really risky and dangerous to update your Java version, and somehow it manages to be both at once. But whatever the reason, the most widely deployed non-LTS version is Java 14, which is over 1 year out of date of support, and no one will patch it for you. So this is the reality of the Java market. People only deploy LTS. 11 is slightly ahead of 8. 17 is coming, but nowhere near ready yet. So why observability? The previous slide tells the story. Cloud native is already our reality. It's where we are. It depends on the market segment. Of course it does. It depends on the maturity of individual companies and individual parts of the industry. The Java market, the software industry, is a hyper object. It is too large and too big to get a sense of, even with any kind of confidence. But we do what we can with bad data and unreliable samples. And that's all that I'm saying about the New Relic data. It's unreliable, it's bad data, it's a skewed sample. Of course it is. But it's just better than anything else we have. Okay, so based on this, what can we say? We see increasing complexity driven on almost every front. Microservice architectures, cloud deployments, the list goes on. I'm sure you know several other entries that can be added to that list. So what is our response? Our response is observability. Observability has come from, I don't know, I change my mind about this all the time. Is it 2 separate routes that it has, or is it 3? Certainly it's at least 2. The old APM segment, application performance monitoring, certainly an automation segment of driving things like Terraform and applications living in containers. Has anyone heard the expression livestock, not pets, to describe their production environment? Yeah? Okay, well that's one of the things that I've seen in the arc of my career. When I started deploying at scale at Morgan Stanley, which is, I dread to actually say this, it's over 18 years ago now. In another couple of years, there will be people at Devox who weren't born when I started doing these kind of large-scale projects, and that scares the hell out of me. We had pets. We had individual servers that we knew the names of, we knew where they were physically located, and they had mutable state. We would upgrade them. We would change the operating system version. We would upgrade their software packages. Now, the way that we deploy things is livestock. That one looks a bit sickly. Shoot it in the head and get another one. And that part of the change feeds into the complexity that leads us to require observability. We don't do observability because it's fun, and well, it is fun, but we don't do it because it's fun or because it's intellectually challenging. We do it because we have to. Because essentially, our world has changed that much. Our release cycles are no longer measured in months, but in days. We no longer have monoliths. We have increasingly complex topologies. And most importantly of all, the architectures that we need to deliver on these days are no longer stable. 15 years ago, it would be months between releases. So an operations team can get an intuition for what can fail. Those days are gone, and they are not coming back. So what does it mean to understand an architecture which changes on a daily basis, where you can never develop any sort of stable intuition? Where you go from something like this, which is what we had 15 years ago, 3-tier architecture, much derided, still extremely useful, very good for deploying against young people because they don't know how powerful this architecture can be. Sometimes you just whip this out of the toolbox and use it because it's the right thing to do. Instead of which, I work for Red Hat. So of course, there has to be a slide which mentions OpenShift, which is our Kubernetes distribution, effectively. Notice how there are no longer clearly separated tiers. Notice how there are different services. Notice also that this is heterogeneous. It's not all Java. The days of all Java shops, which were a thing back in the day, are also gone and not coming back. We have Node in the mix. We have Quarkus, which is native compiled. We also have things which I would regard fundamentally as infrastructure or an appliance like Kafka. Right? Kafka is not an application platform that you put your code into. It's a thing which lives on your network and you send stuff to. And that is my definition of infrastructure. Even worse, we may have things like this, which look nothing like a traditional web architecture at all. I've got a box here marked server. It might equally well say serverless. Nothing would change on this diagram if I change that from server to serverless. This is not your father's architecture or your mother's. It's something new. So that's why we need to understand our cloud-native applications. We need to understand that they're more complex. The topology is more complex to start with, and the topology changes. How can I, as an operations person, understand what happens when a development team may suddenly decide to link 2 services together, send traffic between them, when last week they didn't? If I manually had to guess where to put my monitoring data, suddenly that link becomes important. How will I know that in advance? The answer is that I can't. So the more complex topology, the sources of change, the rapid change, not only that, but also new technologies with genuinely new behaviors. Things like dynamically scaling environments, things like Kubernetes, which starts and restarts things as it will, things like function as a service, AWS Lambda, things like Kafka, things which we did not have in the old world. But our responsibility to customers does not change. The questions we need to answer do not change. What is our health? Where do the errors come from? Why has our service suddenly degraded? Which of the 10 changes that we put into production yesterday was responsible for suddenly our performance numbers going south? And do our customers notice and do they care? Those things do not change. So we need to provide a new perspective on answering these questions. So that leads us then to the question of what is observability. It is conceptually simple, I would say. Lots of people are vague about it, they don't understand, they think it's complicated. I disagree. I would say it's conceptually, at its heart, very simple. You instrument your systems, you instrument your applications and your infrastructure, and you collect data. You send that data out of your system. That part is critical, and I am amazed by the number of people who still get it wrong. You send the data out of the system because you're going to use it to diagnose when your system is broken. If you keep the data in the system, you cannot use the data that's in the system to diagnose the system that's broken because the system is broken. So it is fundamental that that data is sent out of bound and into a separate observability system. This external system stores it, analyzes it, and allows you to visualize it. So this shift from an architecture that you understand and which is fundamentally stable, if it fails, it has, to borrow that old phrase from Donald Rumsfeld, it has known unknowns. It has known failure modes. We live in a world of unknown unknowns. And observability is the response to that. It is the response which says, I don't know what questions I will need to ask when I get into an outage situation. So it's more like experimental science or data science. I have hypotheses. I try them out. I use data. So what sort of interface does an observability system have to an end user, to an SRE, DevOps, management? It looks like an SQL query interface and a visualization tool, because that is what we use it for. We need to track down what is the cause of the problem without preconditions. Underlying all of this, at a deep and theoretical level, are bits of systems control theory. How can we determine the internal state of the system from outside? And what actionable insights can we be afforded by doing so? So, to sum up, 4 basic tenets of why microservice and modern architectures are so complicated. We might also talk about the 3 pillars, and these I will put my hand up and I will say that these are slightly controversial. Not every practitioner, not every person involved in observability thinks that this is a good model. On the other hand, I kind of do. Partly because I spend a lot of my time talking to people who are not yet very far along in their observability journey. So when we want to go down from the sort of high-level theoretical things that I've been talking about, the conceptual level, to start talking about brass tacks and what does this mean to an actual application developer, being able to point to these things and say, look, this is the data that we're talking about. We're talking about metrics, we are talking about logs, and we are talking about traces. And these sorts of data are fundamentally different from each other. Metrics have a regular time cadence. They produce time series with regular intervals. That's one of the things which defines a metric. Timestamp, a name, data, and maybe some metadata as well. A log, well, you're probably thinking of Log4j, the best logging framework in the world. The point about logs is that they provide a single entry. They are events. They occur as a single moment in time. Traces are different again. Traces are about an individual request, an individual transaction. They are scoped to that, and they are not well isolated or well localized or well localized in time. Because on a modern system, a trace starts where a user request enters the system, but that service may call other services. And those services then have a duration in time as well. So it's not about a single point in time. It's about an individual request. Therefore, you can infer other things. Metrics have constant bandwidth, regardless of load. Traces have bandwidth proportional to load. And logs, it's fuzzy. Somewhat related to load, vaguely proportional. Different data types, and they have different uses. And that fundamentally is why I think this is a good model. Because that categorization of the data provides us different ways of handling them. One of the biggest tricks in architecture is to start thinking about your data and whether it has any characteristics that you can exploit when designing the architecture that is to handle it. And by subdividing this into 3 types, we can treat each in a separate way. Distributed trace, each service invocation, what was called, how the request performed, what the data was, what the results were. It starts with a single route, which we call a trace, and then each call to every distributed service underneath it is a span. And that, therefore, tells us what shape the data is. It's a tree structure. Traces form a tree structure of spans. In the old days, when the first websites I wrote were like this. You had a browser and you had a web server. Then you might have a database. So you might have a second tier. Okay, so now what's happening? Well, now the tree, instead of being a single dot, is the root node on the server, and it has one edge and a second vertex, which is the database hop. Okay, now we can add more things in. We now have services which are going across the wire. We still have our root node, and now there are, DB, auth, service. We have three legs on our tree, if you like. And of course, this is only the case where the depth of the tree is one node down. In reality, the auth service may call into the DB and so on and so forth. And so we can actually construct a full tree of services. And here's what they look like. This is rendered in JSON, just for readability. It doesn't have to be. It could be something else as well. This is what a trace looks like. You notice the data that we have on it. The trace ID as a whole. Its span, the parent span, a start and end time, and some statuses and other things as well. So when you're constructing these things, when you're building a distributed system, you need to, and I have kind of fudged this, but let me make it explicit. We are mostly talking about HTTP here. It's very request response orientated, and this type of information is propagated typically by using an HTTP header. So you might look up the W3C trace context header, for example, which will allow us to propagate the information so that each service, which remember is not only a separate JVM, but may actually be on a physically separate host as well. They still need to be able to reconstruct the context, and that is done essentially by ensuring either at a container level or at app level that these headers are added to every outgoing HTTP request to allow the context to be propagated through the network. Okay, so that's the first of these. Just getting a little tiny bit ahead of myself there. So we need to instrument our application. We need to instrument our middleware. The middleware needs to be to know about the context propagation that we need to do. Once we've done that, we then need to somehow ingest the data and store it. And remember, that needs to be a separate system. We then also need search and retrieval. It's no good putting all of this data into a system that we never touch again. I did once do some consulting for a firm that I shall spare the blushes of, where they were running something like 3,000 nodes in AWS for their distributed logging and tracing infrastructure. And I said, okay, how many queries do you do? Like, oh, we've never asked that question. Oh, should we find out? They were doing 100 queries a day. Each query cost them between $200 and $300 in AWS costs. And they could easily have just completely pulled the plug on that. So retrieval matters, particularly if you're concerned about your AWS bill. Finally, and most importantly, is visualization. Visualization is actually the hardest part of what we do in distributed tracing. The usual form is what we call the trace view, which is simply a tree of spans. That's kind of what, so hands up, has anyone used Jaeger? Yeah. So if you've used Jaeger, that's what trace view looks like. And you probably know how useful it is, i.e. better than nothing, but not great. So this is actually a really open area. If anyone wants to go and found a startup to produce better visualizations of distributed tracing, the market's wide open. It doesn't get much better than Jaeger, and Jaeger ain't great. Related to this, of course, is the problem that is, I think, particularly difficult for tracers, is sampling. You cannot collect a trace of every single transaction that you see. It's just too much data. If you think about it, it's probably kilobytes of data per request that comes in. Okay, doesn't sound too much, but if you're receiving 1 million requests a second, that's suddenly a lot of data that you would have to store and process. So you have to sample, and then the question becomes, how do you sample? And do you sample some traces less than others? The complicated ones are probably the interesting ones and the ones that are most likely to break. What about the error cases? And then what about, but you don't know whether it's going to be an error case or not before you start sampling it? There is a whole can of worms about exactly how you sample. What else have we got? Metrics. Specific activity over a time interval, something which is regularly cadenced. And you can talk about all kinds of things. You can talk about system metrics, infrastructure. If anybody's used AWS CloudWatch, you will know what dealing with that is like. Other things as well, web tracking, application, and business metrics as well. There are usually 4 parts to a metric: timestamp, the name of the metric, value, and what are called dimensions. And dimensions are essentially additional metadata. But there is a caveat here. Well, there's 2 caveats here. Firstly, the market leader for metrics is, without a shadow of a doubt, Prometheus. And it doesn't do dimensions. Instead, Prometheus crams all of its metadata into the name. So you actually have to look at the name and figure out what in it is the actual name of the metric and what in it is the actual dimensions, which isn't great. The second caveat is that a dimension is not arbitrary metadata. For something to be a true dimensional metric, it has a property, which is that you can aggregate over the different values for each key, and it will make sense. Okay? Give an example, CPU. If I have a CPU metric, and the name of the metric is system or user, I can add those 2 things together. And it makes sense, because what I get is the total CPU utilization. That's an aggregation which makes sense. If I have another metric, which is temperature, room temperature, and my dimensions are kitchen and bathroom, what meaningful aggregation can I do over those? Can I add them together? Average them? Doesn't really make any semantic sense. So to be really properly a dimensional metric, you have to be able to aggregate in a meaningful way. It's also true that you need to have a potentially low, the piece of jargon is low cardinality. There needs to be a low number of values for each dimension. So system and user CPU, great. I suppose I've got 2 minutes so I can tell this story. When I was implementing metrics at New Relic based on Java Flight Recorder, one of the nice metrics you can get is allocation. And in JFI, you can get it per thread name. So originally, my first implementation included as a dimension the thread name, which works fine right up until the point you put it on an application that's running Drop Wizard. Drop Wizard, for those people that don't know, is a framework, kind of competitor to Spring Boot. It recycles its thread pool every 60 seconds. So the thread names change every 60 seconds. So this works fine in your unit tests, and when you deploy it to a customer, they're like, ooh, there's lots of threads. Yeah, don't do that. So yes, so the cardinality point, dimensions must not only be aggregatable, but they must also have low cardinality as well. And the final point on this slide, the volume does not scale with request traffic. It should, in theory, be of constant order. You can, of course, by the way, misuse these, and people do. People generate what they term a metric, which is actually event-driven. And that will work absolutely fine right up to the point where you plug it into an analysis tool that expects a regular time series, at which point you discover how badly that goes. The third type of data that we care about is logs. Logs are immutable records of discrete events that happen over time. I changed my mind about this as well. It's possible that there are 3 types of logs. The plain text, i.e. the output of log4j or syslog or whatever. Structured, which actually contain effectively a data schema, something like a JSON level of event. And then binary. But it's possible that binary is simply an encoding format and actually is orthogonal to those 2. It's also possible that actually logs subdivide into 2 parts. On the one hand, logs, which have a severity and are generally freeform, and events, which are structured and have no severity level. No one knows what the answer is. As it stands within OpenTelemetry, those are both considered types of log, and that may well change. I think I can be convinced either way. Okay, so those are our data types. It's also worth noting, just be careful of the terminology. There are two types of logging, centralized and distributed. Distributed logs do not mean that they came from a distributed system. The standard logging pattern in a distributed system is centralized logging, where all of the logs go to one place. What can we do with the data? Some observables can be sourced in multiple ways. This, I think, leads to the anti-pattern where people consider metrics and logs to be first class and distributed tracing to be second class. Certain numbers, e.g. the overall response time of a request, can be inferred from log file. Other things which are also important cannot be. So I would advise anyone who thinks that they can do without tracing because they have logs and metrics to potentially rethink that. Aspects of the data we need to care about. Metrics, you trend them, you graph them. The key characteristic that they have which differentiates them from other types of data that we care about is that metrics are aggregatable. You can get an average over a period of time. You can, if it's a counter, it will roll up nicely, as we say. Logs, what can we do with logs? Well, we can grep for results. We can look for things or strings of interest and find them. And their characteristic is that they are discrete point-in-time events. Traces you can decompose. Traces you can find out what happened with an individual request, and their characteristic is that they are request scoped. Another reason why we deal with these things separately. If you want actionable insights from these, you will detect them in various different ways. And depending on exactly what type of action or problem that you want to be made aware of, you will need to look for the data in different places. Also, different people will probably care about it, depending on what type of issue you're facing. So, this is the end of the theory section, and at this point it's a good checkpoint. If you're a cynical person, am I a cynical person? I might be. You might ask, is this just APM with new marketing terms? And here's why I think it's not. It vastly reduces vendor lock-in. If you are using an open source observability protocol like OpenTelemetry, you can just go to another vendor. Right? Your lock-in is substantially reduced. The wire protocols are now open specification. The client components, the things which go in your application, are open source. And the architecture patterns that are out there, it's still an evolving space. There is still plenty of room for us to find new patterns. But certain things are starting to emerge, and certain best practices around how we construct our architecture, both on the application side of how we implement observability in our architecture, and also how we architect observability systems themselves, the places where the data ends up. So this has taken us from a few years ago to this closed loop approach where absolutely everything is closed source, to now the world looks a bit more like this. The instrumentation pieces, OpenTelemetry and the other projects, now have open source instrumentation. Data collection is also open source. We also have open source possibilities for both data processing and visualization. To be perfectly honest, I would say that the vendor products are probably still ahead, both on the data processing and the visualization side. They had a good head start, and there is a lot of sophistication in those vendor products. But open source is catching up. It always does. Open source is a very effective pursuit predator. And it's, the gap is narrowing month by month, I would say. Okay, so this brings us to the architecture, the market as we see it today. Prometheus, which is a metrics-only technology, is by far the most widely used project. This data is from a self-reported survey by the CNCF, the Cloud Native Compute Foundation. Prometheus has got a good chunk of market share. OpenTelemetry is the second most popular project at 49%, and then some other things as well. Interestingly, well, there's quite a few interesting things about this data, but I'll restrict myself to just a couple of points. 72% of respondents feel like they're using a load of different tools. The landscape here is a patchwork, even within a single organization. 34% of people, 1 in 3 people who responded to a survey about observability conducted by the premier observability standards foundation in the world, so slight selection bias in the sample here, 1 in 3 of the people surveyed still said that they didn't think their organization had a coherent strategy. So if you're in that space of being confused and not knowing what to do, you're not alone. Something else which is less obvious, because these numbers are a point in time. And there's one thing I didn't tell you, which is how young a project OpenTelemetry is. Tracing went 1.0 last year. Metrics went 1.0 on Java this week. And yet, it's already at 49%. That is astonishing growth for something which is not even GA. To have achieved those numbers in such a short amount of time is an indication to me that that is where the market is heading. It also employs a very different architecture and architectural style to Prometheus. So it's entirely possible that if people have adopted OpenTelemetry tracing, metrics will be a very easy switch up for them. So I would be very interested to see if we got together again in 12 months' time to see where Prometheus's number was. And to the extent that we talk purely about tracing, OpenTelemetry has eaten the lunch in its domain over everything else. Jaeger, an alternative tracing solution, has pivoted. They are no longer doing the client side or that type of instrumentation. They are now a back-end only project. And the architecture which will be emerging on the purely open source front will be you instrument with OpenTelemetry, you send the traces into a Jaeger backend. Other projects, Open Tracing has already shuttered and folded. Okay, so how are we doing? Okay, I better speed up a bit. All right, so I think I've mostly talked to this. APM monitoring was traditionally dominated by proprietary vendors. Open source has arrived. What is OpenTelemetry? OpenTelemetry is a set of standards and formats and libraries. It is not data ingest. It is not a backend. It is not storage. It is instead, effectively, you can think of it as a client side. If you think of your application as the client, even if it's server code, and the observability system, the thing where you're going to put your data and visualize it, is the server side. OpenTelemetry does the client piece, and that is basically it. What else? It is an example of a system, and I often think that there are 2 types of architectural styles. There are small computers that get big, and there are big computers that get small. And Unix, for example, is an example of a system which was a small computer that got big. OpenTelemetry is a big computer. It's a big system. It was designed by folks who were used to dealing with Google scale and Netflix and that level of hyperscaling. And it turns out that with the right architectural decisions, you can make it scale effectively down to the middle size and even to the small. But one of the key points about that, and there's a reason why I'm mentioning this now, and I'll come back to it, is aggregation. In OpenTelemetry, you must be able to aggregate data cleanly. And it may well be the case that in a large enough deployment, you will aggregate multiple times because there's too much data to do anything else. Aggregation of data is always lossy. Unlike compression, which can sometimes be reversible, aggregation is always a loss-based process in information theoretic terms. OpenTelemetry is also extremely flexible. It does not dictate to you what your architecture for your observability system needs to look like. There are multiple options. There are 3.5, 4 options, depending on how you count them. OpenTelemetry supports all of them. It is explicitly cross-platform. It is a standard. It is not Java-specific. The implementations are of varying maturity. Java is one of the most mature. Node, Go, .NET, also very mature. Python, PHP, Rust, and then the long tail. It does work with bare metal and VMs. It does not require a cloud, but it was designed to be a cloud-first technology. This slightly wonky diagram, which I did not draw, but instead stole from the OpenTelemetry website, shows us the major components of it. And it also shows the points of view. For application owners, which I guess is basically the folks here, what you care about is the SDK. The SDK provides you with an API and an implementation of that API, which you will use to instrument your applications. Other folks who want to actually work on the protocol itself and to build instrumentation, we would have a slightly different view. But for the purposes of this talk, the SDK is the thing that you care about. This is a long-term supported release, so the API will be guaranteed to be supported by the community for 3 years. Various vendors may well make additional support guarantees. I work for Red Hat, and I can say that we have not yet publicly announced any support for OpenTelemetry as of right now. So I think this basically just repeats what was on the last slide. So if we wanted to break down what you get when you get the OpenTelemetry box, what's inside it, there are really 3 parts to it. One of them was on the slightly chunky diagram that I showed you, which is the specification piece. It contains an API, an SDK, and a description of data. This is sometimes referred to as the semantic conventions for data. And it actually turns out to be one of the trickiest things to get right. Because what does a particular data point mean? Especially if you need to do this in a cross-language way. You know, thread count. What does thread count mean to a Python application? Anybody got any ideas? I don't. So trying to draft a standard which is both broad enough to be inclusive and yet able to be specific in a cross-functional sense is very, very difficult. Okay? The slightly easier piece is the instrumentation, because this is a big piece. I mean, in terms of the amount of effort involved in these are not equal-sized chunks. The instrumentation is huge. It's a very, very large amount of work, but it is one-off work. Once you've written the instrumentation for a language and for a framework, you don't have to write it again. And this, by the way, is what drives the dynamic behind the move to open source. If you're a proprietary company, software has, unless I'm mistaken, only ever gotten more complex. New languages, new frameworks, new things that people care about. There's only ever more and more and more of it. If you're a proprietary software company that requires to build an instrumentation for it, you are building instrumentation forever. And that work is duplicated between you and your competitor and the competitor and the competitor and so on. At some point, the market dynamic flips and it actually becomes much more cost effective to collaborate with your competitors on an open source core. Those of us who have been around for a while, let's say, will have seen that dynamic play out in other markets, in other verticals within software. All of this has happened before, and it is now happening, in observability. So the instrumentation piece is where that consolidation is happening. It's becoming commoditized, and value for the proprietary software vendors is migrating up the stack as the community agrees upon an open source core. So it's a big piece, but it is one-off work. Finally is the collector, and yeah, I do sometimes have absolutely lost causes in technology, which I continue to support long after everyone else has given up. The naming of this piece, the collector, is one of those. It's a dumb name, because it doesn't collect data, it doesn't store it. It's a switching station, it's a protocol terminator, it's a network endpoint. But do any of those things mean that it collects data? Yep, probably the last person still fighting that battle, but never mind. It's actually a really nice piece of code. I just wish it was called something different. Okay, so what is the current status of OpenTelemetry? Distributed tracing is at 1.0. You can track this process of single request. It replaces open tracing. It replaces Jaeger. It's there. It's already the market leader. Metrics is literally about to release. Annoyingly, the Java version number and the standard version number are not aligned. So the Java version number, which is coming out, is 1.14. 1.14 is a 1.0 version of the standard, and that starts the stopwatch. At this point, as soon as that happens, OpenTelemetry is considered GA, and the support clock starts. So if you are thinking about deploying stuff, you can go whenever you like. subject to conditions about being available in other languages. But for Java, we're ready to go. Logging. Logging is less of a good story, I'm afraid. It's still in a draft state, and it's not expected to reach 1.0 until late 2022, or possibly next year. But given that I'm talking to a room full of Java programmers, I have some good news. The good news is you don't have to care. Why don't you have to care? Because Java already has a logging story. Log4j, or SLF4j, or any number of innumerable other Java logging. When Otel logging shows up, do you know what it's going to look like? It's going to look like an exporter. That's it. You'll add another dependency onto your class path, and you will configure your logging framework to point at OpenTelemetry logging. And you're done. So of all the pieces, and other languages, by the way, are having a real bunfight about this. Because languages that have never standardized on logging frameworks and don't have Java's enormous amounts of baggage and difficulty with dealing with logging, but we all know that it's there. Other languages, not so much. So they're really struggling with what their API should look like and how logging should work. For us, it will fit into what already exists. OK, so I think I've talked about competitors. So let's move on to talk about Java specifically. So how do we get started? Well, the other thing which I need to tell you about is manual versus automatic instrumentation. Manual is full control. You write a piece of Java code which says, start me a span, start me a trace. From the trace, recover the context. Start me a span for this distributed service, and so on and so on and so on. Emit me a metric. That's manual. You write that. It appears in the source code of your application. You have a direct dependency on the OpenTelemetry libraries, and you check it in. Full control. Yay. Oh, except that. Remember what I said about 20 minutes ago? About complexity, about how the things change, about how some other team you may never even heard of in your organization suddenly starts calling you directly. Well, if you haven't instrumented everything properly, you now have a blind spot. Because the topology, your application architecture changed. And now, something which is not instrumented is getting hammered. Good luck finding that. So for that reason, other people prefer to use automatic instrumentation. There's two ways of doing this. You either use a Java agent, or you use a framework which supports it directly. Within OpenTelemetry, I work for Red Hat, so Quarkus directly supports OpenTelemetry without the need for a Java agent, and it works in native compiled mode. So if you are interested in native compilation and deploying very short-lived Java applications into the cloud, come and talk to us about Quarkus. Okay? Now, there is no such thing as a free lunch. There never is. If you go down the automatic route, you still require configuration because you can't instrument everything. You still need to actually potentially fine-tune how you're going to configure things. You still have an impact on startup time, and there are still potentially performance penalties, especially in the Java agent mode. But, those are the facts of life. You pays your money and you takes your choice. For people that want to adopt this, there are three main projects that you need to care about. They're all under the OpenTelemetry organization on GitHub. There is the OpenTelemetry Java, which is the manual instrumentation, including the API and the SDK. There is OpenTelemetry-Java-instrumentation, which contains a load of the automatic instrumentation you'll need, and it also contains the OpenTelemetry Java agent. The third repo, which you may or may not find useful, is OpenTelemetry-Java-contrib. This is our incubator. This is where stuff goes before it may migrate and graduate into one of the other two projects. It also contains a bunch of helpful and standalone things. Two of the ones that I want to focus on are the JMX metric gathering and the JFR support, which is my project. That's still all in beta, but it's coming along quite nicely. We're mostly focused on traces and metrics. Now that metrics is hitting 1.0, we'll probably start spinning up more onto logs as well. A question which someone asked me earlier today, which I think is probably useful to point out now as well. The other thing which we will be working on very closely is micrometer integration. Hands up, who uses micrometer? Whoa, Whoa, okay. Like 4 people. What's everybody else using? I'm surprised by that. Micrometer is, I think, probably the most effective of the metrics frameworks that are out there. So I'm genuinely shocked to see so few people using it. People are using something else. Have a look at Micrometer. So how will all this look to you as an application developer? Well, you have an end user application, you have libraries, that will be instrumented for you. For a manual call, you will go through the API and down and out to the exporters. So not a huge surprise. I'll just wait while folks take pictures. And yeah, this is where the API and the SDK split is the way that it is. It is possible that someone may decide to develop an alternative implementation. I might speculate that certain proprietary companies who still haven't come to open source yet might have insisted on this in order to ensure that they had the possibility of producing a proprietary implementation. Maybe. But in reality, I think that almost everybody will continue to use the primary SDK and the main implementation. Right, so the key components are the API, the SDK, and the exporter. You need some configuration. It's a very well-designed stack, actually, I have to say. Working with the folks within the OpenTelemetry project has been an absolute delight. They are really, really strict about the quality and the cleanliness of the split between the API and the SDK. It's been occasionally annoying, but they actually have made the right calls about exactly what should be made public, i.e. as little as possible. And it's been done in the sure and certain knowledge that anything that you ever make public, somebody will come to depend upon sooner or later. So it's a large and complex project. There's no getting away from that, but it has been very, very well architected. I think I've said all of that. Right. So what do we expose from within metrics? Counters, measures, and observers. That's it. Those are your only instruments that are available, and that is basically solidified now, I think. The aggregation is extremely important. It's performed by the SDK, not by the app code, and by design, the developer has limited control over the aggregation. There's a background thread which comes in and does a bunch of stuff for you, and you don't get much say about how it's handled. Some of the aggregations that it performs, like sum and count and last value, are available. Histograms, and particularly what's the expression for them? Binary histograms? There's a new form of histogram that's being developed as part of OpenTelemetry. I can't remember quite what the name of it is, but it's designed to be able to aggregate more easily. Yeah, I've got 3 minutes. So yeah, we're doing some stuff with JFR. Hands up who's used JFR. Okay, that should be the other way around. Instead of the 4 hands that went up, that should have been everybody's hand. If you're running Hotspot JVM, which I guess everybody is, JFR is a wealth of information that you did not know about. It is probably the finest performance profiling and debugging tool I've ever seen, and you should learn about it and go and find out how it works. It has 2 modes in everything before Java 17, given that we don't care about non-LTS versions. It produces an output file per machine, which of course is more or less useless for observability. Java 17 has the ability to set up a thread and receive callbacks when performance events happen. It's extremely flexible. It's really nice. It's what I'm building the OpenTelemetry JFR support on top of. So I advise people to check out. By the way, I just take a straw poll. Is anyone running Java 17 in production yet? More people than are using JFR. That's terrible. Okay, I'd actually like to chat to people. So if you see me at the Red Hat booth afterwards, if anyone is running 17 in production, come and see me. I'd like to ask a couple of questions if I might. Okay, so I am out of time. So basically, I will just skip all the way through to say that observability is a growing trend for cloud native, increasing number of OpenTelemetry users. Otel has got, I think, is going to be a really big driver in the next 12 to 18 months. We, as the Java community, have great sources of data for Otel, including JFR, but not limited to that. And there's active work, including by me, to bring JFR and Otel together. Thank you very much. I have a new book coming out called The Well-Grounded Java Developer Second Edition. It is finished. You can get all of the chapters available online now. Physical books will show up in the next few months. And Friday morning, tomorrow morning break, if you come to the Red Hat booth, I will be signing and giving away copies of one of my earlier books. Thank you very much. I hope you enjoyed it. We have 1 minute if anyone has a question. Yeah, at the back. I'll drink some water.
Sorry, I am a little confused about your opinion on Micrometer and OpenTelemetry metrics. So you said everyone should use Micrometer?
Micrometer is a really, really nice project. And one of the things about it is that one of the next projects that we'll be working on within OpenTelemetry will be an exporter from Micrometer to OpenTelemetry, right? So if you're using Micrometer, it's about flexibility. It's about lack of lock-in. You'll be able to switch over to use Micrometer and OpenTelemetry as the wire protocol. That was the point.
Okay, thanks.
One more? Any more? No? Okay. Thanks, folks. See you tomorrow. Come get a book.